Hi everybody, NoPlum99 here, responding to Philos71, 5 questions every intelligent atheist must answer. Damn good video, beautiful slick video this guy's made some very interesting questions. I think I've done some interesting answers. You can be the judge of that. You can't answer these things with the same brevity as you can ask them. Appreciate that, please. But I've done my best to be as brief as I can. I've spread it over 3 videos, about 20 minutes, something like that. I think they're worth watching. I think they're good answers. Let's get on with the first answer. Okay, question 1 is a very, very good question. You ask, are atheists using chance in the same way as Christians use God of the gaps? You say that you're specifically interested in abiogenesis. I read the annotation, but I want to start off. You talk about natural selection. You say you're not happy with natural selection in this using chance in this way. So I'm going to start off with that, then refer back. I want to give you an example of birds. There are 4 orders of birds that have opsins tuned to violet light. But there are species within those orders that are tuned to ultraviolet light. That's happened 4 times in 4 separate orders. What evolutionists say is that this has happened 4 separate times, 4 separate examples of the same evolution. We actually know by studying the genome exactly what point mutation, because it is a point mutation in this case, on the genome causes this to happen. We know exactly the point that happens, exactly the letter that has to change. It has to change from an A to a T. The chance, generation on generation, for any single act of reproduction, for any single birth, is about 500 million to 1 of any specific letter mutating, a point mutation. Just shows you how what high fidelity that the system has. It's only 500 million to 1, or it's as high as 500 million to 1. Now you have 2 copies of every gene, okay? So you've got twice that chance. So in any particular reproductive event, you've got a 250 to million 1 chance. But it has to go from an A to a T, not an A to a G or an A to a C, so that's a 750 million to 1 chance. We're now quantifying it. We're not just saying there's a chance, we're quantifying it. We're saying exactly what the change has to be, exactly what the statistical chance is. 750 million to 1, it sounds like a total long shot. But just you imagine in your population of birds, let's say that for each generation of offspring there's 1 million offspring. That's not a huge number, is it? 1 million offspring for a worldwide population for that, for a particular species of birds. 1 million offspring. If they breed every year and have 1 million offspring every year, it's only going to take 750 years on average to see this change. In 7,500 years, you're going to have had it happen 10 times. What we're talking about is when you start to get into long periods of time, like 1 million years, although this is a chance event, chance doesn't enter into it anymore. These things are bound to have happened, and this is the thing with natural selection. These mutations we're talking about, although the chance of them happening on any specific reproductive event is very, very small, when you multiply it by the huge numbers of reproductive events, it's bound to have happened. All the changes that could have happened will have happened. The only thing that then decides is natural selection then decides which ones are beneficial and which ones aren't. It weeds out the ones that aren't beneficial, it keeps the ones that are beneficial. It's a sorting process. Let's feed this back into this problem of abiogenesis. And this abiogenesis thing is a problem because we no longer have this ultra-sterile petri dish of a planet where all this chemistry can go on anymore, because this whole planet is contaminated with DNA-based life. Any raw materials that turn up anywhere are immediately consumed by DNA-based life before they have a chance of fostering any kind of abiogenetic reaction, of any kind of non-DNA based reproducing molecular event that could actually start some kind of chain going on. But we can look at some of the statistics. You can imagine on a planet the size of this, just the overwhelming number of chemical reactions that would take place. There are over 100 billion stars in this in this galaxy. There are over 100 billion galaxies in the observable universe. Let me just run those numbers there again. Over 100 billion stars in this galaxy alone, over 100 billion galaxies in the observable universe. However many more billions of galaxies outside of the observable universe, we can only guess at. How many solar systems with planets that support life are going to exist within those billions of stars in billions of galaxies? It's going to be a huge number. We have no way of knowing how many it is, but you can well imagine that we're not going to be the only planet where this unimaginable number of chemical reactions are going to go on. There's an almost unimaginable number of planets where an unimaginable number of chemical reactions could be going on, all of which perhaps, if there is a mechanism, could be potential chance events for this mechanism to get underway. So we can't put any numbers on it. I'll grant you that, because we don't know what the mechanism is. We don't know how many solar systems there are out there with potentially life-supporting planets or satellites of planets. We don't know that, so we can't give you any firm numbers. But don't disregard chance. Don't disregard chance, because you could have a real long-shot chemical event. But you're talking such a huge number of possible scenarios out there, of chemical reactions out there, and it only has to happen once in any one of those reactions. So the fact it could be a chance event is a very real possibility, just as I showed you with a natural selection example.